All right, so 6.1 part 2 is all about exponents, and I know we've been dealing with exponents, and you guys have been getting really good about how to know when to simplify and when to cross off and stuff. But now I'm going to throw two of my favorite things at you, and those are negative and zero exponents. So let's just talk about, before we get into the actual problems, let's do some brainstorming. So this is like one of my favorite things to explain while teaching. Okay, so let's talk about something. What is 2 to the first power? Well, that's 2. What's 2 to the second power? 3. 2 to the third power. 2 times 2 times 2. Oh, wait, what am I doing? Not 2 to the second power is 4. I don't know why I put 3. Sorry, 2 to the second power is 4. 2 to the third power would be 8. And then we'll do one more. 2 to the fourth power would be 16. Okay, so what is the relationship that you notice? What is happening each time if you work backwards, if you go down on the right side? So from 16 to 8, that's being divided by 2. 8 to 4, divided by 2. 4 to 2, divided by 2. Right? And if you notice, the exponents are decreasing by 1. So what would 2 to the 0 power be? Well, some people instantly want to think 0, but it's not. So you would divide 2 by 2 one more time, and you would get 1. Okay, this works every single time. So I'm going to write it off to the side. Anything to the 0 power is always 1. Okay, anything to the 0 power is always, always, always 1. Okay, so now let's talk about if we kept going, so we went down to 0, what would happen if we went 2 to the negative 1 power? Well, we would divide by 2 again. What's 1 divided by 2? Well, that's 1/2. Let's do 2 to the negative 2 power. Divide by 2 again. That would be, so 1/2 divided by 2 would be 1/4. 2 to the negative 3 power would be 1/2 of a 4th, which would be 1/8. And we'll do one more for good measure, and we would do 1/8 divided by 2 would be 1/16. So what do you notice? Well, if you look at 2 to the 4th and 2 to the negative 4th, they're upside down. What is that called? Well, the math word for it is reciprocal. So they are reciprocals of each other. So 2 to the 3rd, 2 to the negative 3rd, they're reciprocals, 8 and 1/8, 4 and 1/4, 2 and 1/2. And then you'll notice 2 to the 0 power is kind of the middle point, and it is 1. So this works every single time. Okay, so it doesn't matter if it's a number or a variable or whatever, they are going to be reciprocals of each other. Anytime you have a negative exponent, and anytime you have something to the 0 power, it's always going to be 1. Anytime you see that, you should get a little bit excited because you're like, sweet, that's easy, cross it off, put a 1. Okay, so now let's do a problem. So this is x to the negative 1 power. So I'm going to put this over 1 because it kind of helps you see a little bit better. So anytime you have a negative exponent, you're going to, I always circle it, and that means, therefore that means I know that I need to flip it to its reciprocal. So it would be x to the first on the bottom. I always say flip it over the line, get rid of the negative sign. Okay, there's nothing on top, so what do you put? You put a 1. Okay, just like 2 to the negative 1 power is 1/2, x to the negative 1 power is 1 over x to the 4th, or x to the first, or you could just say 1 over x. Okay, let's do another one. Okay, now I have 1 over x to the negative 1 power. Well, anytime you have a negative 1 power, you're going to flip it to its reciprocal, so I circle it. That's what I need to flip, so it's now going to be in the numerator. Okay, if there's nothing in the denominator, what do you put? 1. So you could leave it like that, or it would just be x. Okay, now here we go. We got a different one. So how many things have a negative exponent? And the answer is just one. So how many things are we flipping? One. What are we flipping? Well, the only thing with a negative exponent is this x, because remember you could write it as 3 times x to the negative 1. So don't flip the 3, only the x, because that's, like I said, that's the only thing with a negative exponent. So then it will be in your denominator, so it would be x to the first. And then the 3 is still in the numerator because it did not flip, so it stays up there. That's the only thing left. And the y is just hanging out, so it's going to be in the bottom. So now I have 3 over x to the first y, or you don't have to write x to the first power. You could have just written 3 over xy, because we know anytime there is no exponent, it's 1. All right, now D. Okay, this one's getting a little harder. How many things am I flipping? Just one, so just that x. And this is why I circle it, because it kind of helps you break up the pieces. So now I have 9 on top, y to the 4th on top, because those didn't move. And now I have x to the 3rd and an x. Are we finished? And the answer is no. We still have 2 terms with x's in them, so we want to always combine to where there's only 1 term with x's in them. So x to the 3rd times x would give you x to the 4th, and then 9y to the 4th is still on top. Double check. Are there multiple terms with x's? No. Multiple terms with y's? No. 9, there's nothing to reduce it with. And one huge thing, are there any negative exponents left in the equation? No, so we are done. Because you never leave negative exponents in your answer. Okay, it's not complete. It's you don't do it. You got to simplify it out or flip it over. Same thing. Okay, now we got another one. So how many things have a negative exponent? 2 of them, so this and this. So we're flipping both of those. So I would have x to the 3rd, y to the 4th. Flip those, and then you still have that z to the 3rd. It's not flipping. Nothing on top, so you put a 1. Okay, this is a different rule. If you remember from Algebra 1, which you might not because I know it's been a minute, this is called power of a power. So how you do this, first I'm going to write 3 is to the first power, so just keep that in mind because there is no exponent, so it's a 1. So when there's an exponent outside of your parentheses, you have to distribute that in to the exponents. So just like you do with distributing a number out front, you're distributing into the exponents, not the numbers themselves. So this is going to be 3 to the 1 times negative 1, which would be negative 1, over x times 2, or x to the 2 times negative 1, which would be negative 2. Okay, so I just got rid of those parentheses by distributing that in. Am I finished? Absolutely not. There's negative exponents. We're not going to leave those. So we're flipping those 2. Flip it over the line, get rid of the negative sign. Okay, and there's your answer. The 1 is optional on that. G, 8 to the 0 power. Woohoo, get excited. I know that wasn't very exciting of me. 8 to the 0 power is 1, right? All day, every day. What is 34,567 to the 0 power? 1. What is x to the 0 power? 1. Easy, okay? Now let's put those 2 things together. So on these, there's a bunch of different ways to look at it and a bunch of different ways to start. It's one of the things I love about it. So what do you see first to do? Well, everybody might have a different answer. I see 3 to the 0 power. I'm getting rid of that. That's the easiest thing. It's 1. All right, and then we have our negative exponent. So I know I'm going to flip this and flip this. So that would give me y to the 4th, still is on top, then z to the 3rd, and then x to the 3rd on the bottom. If you notice, I wrote the y first and then the z. If you flip-flopped those two around, I would not count it wrong, but math etiquette is you write it in alphabetical order, so it's kind of a good habit to get into. So that's why I wrote the y first. And also, if you would like to, you could have written the 1 there. It doesn't matter. It doesn't change the answer. Either way is fine. I know some people like to write that. All right, K. So we have that power of a power rule. So I'm going to write that 3 to the first power. Now I'm taking this 3 and I'm distributing it in. So this is going to be 3 to the third, because 1 times 3, x to the 6th, because 2 times 3. All right, now on this, some people may be tempted to leave your answer like this. If you have a number to an exponent that you can raise to that power, I do want you to multiply it out. I don't want you to just leave it as 3 to the third. So 3 to the third is 27, we know from the last lesson. And so this would be 27x to the 6th is how I want you to write it. Okay, is this the last one? Last one. Cool. So now, if you notice, it's the exact same thing, except now I have a -3 outside instead of a +3. No big deal. We're going to treat it the exact same. So we're going to distribute this in. So I have 3 to the -3rd times x to the -6th. Okay. All right, can we leave it? Nope. We have 2 negative exponents, so we are going to flip them to the reciprocal. So this would be 3 to the third on the bottom times x to the 6th. There's nothing on top, so we put a 1. All right, can I leave it like that? No, but we're really close. Last thing, we need to simplify that 3 to the third. So this will be 1 over 27x to the 6th. So if you notice, it's just like that other one, except it's the reciprocal, which makes sense because there was a negative exponent. All right, that is it for part 2. Thanks for watching and have a great rest of your day.